So Frank, tell us about your building that used to be here. What was this?
Hey, well, you are standing right in the office. That was the entrance there. My desk was here. My phone was there. That heater I was talking about was a resistor grid.
Resistor grid.
And I had laid it flat, and I had hooked it up to 110 volts. And then we had a window here, and I used to hang. I had a rack there. I hung the Puget Power guys and the railroad guys' clothes there to dry them. And then I used to work with the T1 too. So anyway, here's that, and this is a slanted wall here. This is where the window was, looked into the substation. And this is where the door was to go in there. And then right here was what I called a Ouija board. That was the control, start and running Renton. On the Rocky Mountain Division, you'll see in their substation on top of their desk maybe 3 panels where the substation operator is operating those 3 substations by remote from this one. But over here, the remote panel for Renton wasn't anything like that. It was a stand-up thing, looked like a pinball machine. And I could raise voltage and lower voltage, start and shut down the MG sets, and so on and so forth. So just as we did at Cle Elum, you come in here, and this was where we were down in the basement, and this was the exciter here. That's MG set. I don't know
motor
what
generator set sitting here then.
Yeah, we had place for 3, but the Cedar Falls. All the time I was there was only 2, and they had already used the 2 from Tacoma elsewhere. So we had such a good arrangement power-wise between Hyack and Cedar Falls that we could handle pretty much anything. There was one possibility that I was going to run a little Joe, and I was kind of gearing up for that, but then it didn't come to pass. So the last time I saw Little Joe's was in Seattle at a wrecking yard.
Yeah, I remember those days. Those were not happy days.
No, they weren't. So here you can see these are the conduits, the holes from the conduits. So the switchboard sat right about here. And all that stuff that you saw in the back of the switchboards, all those wires and everything went down through there, went underneath here, came up to the MG sets. And one of the things that's missing out here, must be where these bushes are, was the pedestals for the oil circuit breakers for the 115,000 volt line. The 115,000 volts came up from Snoqualmie, and right about where that concrete is broken, right about down over the bank there, that 3-phase power came in, and it came off of a single pole with 3 bushings like this.
Wow.
And then it went to this rack that I was talking about.
Yeah.
And there it was separated. It came in 3, like 1, 2, 3. Yeah, 1, 2, 3. How is it? Anyway, something like that. That was probably one of the most difficult switches that anybody had to do on a railroad. Anyway, it got done. So now here, this is where the JR breaker used to sit. It was right here. So okay, here's the wiring. Here's the wiring for the JR breaker.
What is a JR breaker?
That's a 3,400 volt, 3,400 amp circuit breaker. Big stuff, like this.
Yeah.
And so this was operated off of a small control panel that was here on the switchboard. If you had like 2 overloads, you had, say you got tripped out 2 times in a row, the little coils in that, what tripped it out would throw this breaker, see?
Oh.
So when you had a trip out, that threw the breaker. And so then what would happen was you could not close this breaker from that wall. So you got to come over here and get down on your hands and knees, and you have like a baseball bat, and it's shoved into the hole here, and you put it inside. It was almost like a railroad track jack, and you push that thing down just as hard and as fast as you could put it. I actually tried it standing on it, but the arc chute, see that the breaker sat about that high. Then the arc chute sat up here about this high. I ducked like this because the flame could come out through the arc chute. So, and then you go down there and say, 1, 2, 3. And if it worked, great. If it didn't work, shit. Actually, if it didn't work, it was time to call somebody that, what the hell's going on? Because
something was wrong.
Because if you energize it, you could possibly electrocute somebody
Right.
that might be involved in a derailment, or we had like 20 or 30 seconds after a trip out to get back on the line. And so there's a short time frame that we would energize a wire before the breakers trip that could hurt somebody.
Sure could. Yeah, absolutely.
The things are much faster now than what they used to be, but you'll see Puget Energy quite often. You know, your lights might blink at your house, and so they re-energize the circuit, and then the lights might go out. Well, there's a tree in the wire someplace. But in that little blink, if you pulled a plug out of the wall and you had your fingers on the plug, you're going to get bit.
Yeah, yeah.
So anyway, back to this. So this was just, when I first came in '69, what you see here was sand, and it was a heavy paint that they put on, and it was just all over the place. So I made it look like a hospital room. That's what they told me. I cleaned it all up, and then you had all these white specks on the MG set and sand in the commutators. I must have worked a year. But boy, old Cy Krauskup, he was head of Substation. He came in and he just thought it was great.
Oh, cool. That's
So
great.
that's a starting and running switch pad. Yeah, that's a starting and running switch pad, and there should have been another one over here. I don't know why it's not, but okay, maybe it was here. Here you can, once again, you can see where the wires came up through the conduit.
Right, right.
And so this had to be for that set. So there must be, this would be where the door was, like we went into the transformer room at Cle Elum.
Okay.
That would be where the door was. So the other starting and running switch, there's something like that down in here. And then those dials that I showed you, they sat right up here. And you closed the starting switch and you looked at that, and it would pull that 115,000 volts down to like 500 volts for just very short period of time. You could see it coming back. So when it's coming back, then I'm walking around the MG set, checking to be sure the slinger rings are going, and there's no raccoons or anything coming out. So then I get back over here, and then I stand here for a second, and I look up there, and the meter is dead steady. And so then I pop this starting switch out, and I'll close this running switch just like that. Just exactly like a boom, boom.
Okay.
And then I check that meter, and that meter is dead solid. And so then I do the same thing over there, because I usually ran both sets. So then I do that, and then I come to the switchboard here, and I would check my voltage and the amperage that's on that the train is drawing by getting that information off of the trolley and the feeder cable. And then I would then I would close the disconnect. Now the disconnect was those things that you saw above the switchboard,
Right.
those panels, and they were like this. The disconnect was about this size, and heaven help you if you did open or close it when you were under load. So anyway, I would close that. I mean, the MG sets are running. Everything's solid. I got power over here, so I know that I'm getting power in through those switches that are in the substation that I showed you, and so the train right now might be Bagley Junction. So I close that disconnect in, do both of them at the same, one right after the other, and then make sure everything's stable, and then I would push the button on the circuit breakers and close the circuit breaker, and bingo, right? So I usually had it set up so it would come on at 3,000 volts.
Right.
I'd come on a line at 3,000 volts, and then let's say the train might be at the siding at Bagley Junction, so it's just sitting there waiting for 201 or something to go by. If it was morning, it would be 201. 201 went to Black River, and later on it was my responsibility to have a switch crew out there and get those hot cars off of that 201 train and have them in Seattle in an hour. So even if it was one car, which I got my tit in the ringer about, but
For like Sears and people like that, right?
yeah, Sears. Yeah, especially Sears.
Especially Sears.
They might be running a sale on freezers, you know. There's
You need that car full of freezers.
So like I say, so I'm at 3,000 volts, and then so I might see a little jiggle like this on the meters, and so in order for me to know that, I can't be sitting at the desk. So I'm out here watching, and I see that jiggle, so right away then I up the voltage to maybe even 3,400. If the depot, or if I hear the if I hear dispatch tell me, say something about tonnage, you know, the train might be calling in the dispatch, say from Black River, and say, well, we figure we've got about 1,800 ton here. So what can we pick up at Cedar Falls? Should we make a pickup at Cedar Falls, or should we run for it? So then I might, if he's coming up here with 1,800 ton out of Bagley Junction, I might boost the power up to 3,400 volts. But I have Renton running too to back me up. So now we got about 7,000 volts that we're providing to about 5,000 horsepower. And so then I can tell they're in Cedar Falls, because I can tell there's no draw. So then I drop down to 3,000. I leave Renton up, and then I might call Jim Urban at the depot and ask him what kind of what's going on. Do we have another westbound come or work extra west, or are they going to go to the beanery, or what's going on? So he might tell me, no, Frank, they're heading out right away. They're doubling over now. And so then I'd be all ready. I'd stand at the switchboard, and also I could hear him. I could hear him. I had good hearing then. I could hear him down there coming. And so when he went by the substation, I would still be right at 3,000. And by the time he got past the houses here, see the siding, the main line and the siding were run right along here. And then the siding cut in just past the bungalows, went into the main. And so once the caboose got there, the block signal was red. So then I would come up to 3,100. I'd turn it up to 3,100. And then when it went yellow, I turned it up to 3,200. When it went green, I turned it up to 3,400. And then by this time, I'm on the phone talking to Hayek and telling Bill Bibby, hey, Bill, he's coming out with 2,400 tons that are come on at 3,400. And so he would do that. And most of the time, we made it across. The one time, I think I told you that they had to back down. But And where they're pointing the finger at me about the screw up, it's the conductor that screwed up. He didn't know how to add. So, and that of course was where those transformers were.
Right.
They filled the damn holes where the tanks used to be that I had to climb in. This is where the oil switch breakers were for disconnecting that stuff. And we did have a bathroom. I noticed that Cleveland didn't have but we had a bathroom over there. And I'm here to tell you, in high humidity days, you could walk through that doorway and go to the bathroom. And this set of disconnects here would make your hair stand up.
Now, didn't you have to paint that toilet seat?
Yeah, I painted the toilet seat with Whiptol, insulating paint. and the guys, that's what the guys from Puget Powers, they laughed to me to hell, you know. But the one day when they'd been in the bathroom, I mean, the guys had been going, I had to clean the bathroom twice a day when they were all, I had 3-4 crews here. And so 2 or 3 of them were bullshitting. They come out of the bathroom and they're walking along the switchboard and they heard a zit, zit, zit. And they said, hey Frank, what's that? Oh, that's 4400 going up the wall. That was a signal circuit. The signal circuit was 4400 volts. So, yeah, interesting. I don't know what else you need.
I think we're good, Frank.
Yeah.
I think we're good. You were just
Yeah.
awesome today.
I don't think you're gonna get anything else. I'm really, really interested to, as I